Alright, hopefully you thought about why the general book design will actually violate the single choice principle, especially when we have so many distinct dynamic types, right? Let's now try to see if you got the right answer. The answer goes like this, okay? Let's now make some, set up some scenario, just general scenario. Let's say we got 100 different dynamic types. We got C1, C2, all the way up to C100, okay? Just symbolic, just make it easier. You can see we got record number 1, record number 2, all the way to record number 100. We got 100 reference variables, which we're going to use to really add into the book. And statically, you can see each record is declared as the objects. That's why when you use C1, C2, C100, they're all valid because every one of them is simply the descendants of the objects, right? Hopefully you see the setup. And then we are trying to add into the book. So b.add, we call this add method 100 times. And then the first argument should just be some names, which I just omit the details, right? So we are trying to add record number 1, record number 2, all the way to record 100. So we have added all the 100 records into the book. And now, how many different dynamic types have we got in the book? We got 100 because for record number 1, it has the dynamic type C1. And record number 2, it has a different dynamic type C2. And similarly, all the way up to when record 100 that's being added, it has the different dynamic type C100. Right? That's the book we're talking about. Right, let's now say this. Every time you want to retrieve something from the book, right? Before I do that, let me just say one more thing here. You can think about this part over here, add, and also add over here. So these are all about storage. And we want to actually retrieve from the book. Every time you want to retrieve from the book, as we said before, you have to use a combination of instance of and also typecasting to know what relevant method you can call. For example, if I say if I want to say b.get Jim, I know that statically I can only assume the return value is only just an object, which we discussed earlier, right? After this line, we have to see what are the record that's just retrieved is dynamically, right? So this is for retrieval. And for this particular record, we want to see whether its dynamic type is C1 or all the way up to C100, right? That's why we are using a long, exhaustive if then else if conditional statements, right? In case the dynamic type is actually C1, so we know that dynamically the record can fulfill the expectation on C1. So that's why we can cast that into C1. So this will be a safe cast. All right. So if you let me make one more notes. You can see this cast over here will be runtime, will be the class cast exception free because we're doing such check over here, right? So having this check before doing the cast, we know that we can prevent class cast exception. However, we have to do this exhaustively for all the possible dynamic types. So we got to do it for 100 times. And this is only for one single retrieval. What if we got another one? Let's say we want to retrieve the record for Jeremy. And Jeremy, let's say maybe you know where Jeremy is actually stored in the book. Maybe you wouldn't know. You're simply just a user, right? So you're retrieving something back from the book. You know that statically it's only just an object. So you got to repeat exactly the same pattern over here. Well, you got to repeat exactly the same pattern over here to do a safe cast, right? Let me just make a conclusion over here. And then let me ask you the question to really conclude, okay? The same exhaustive checks on the dynamic type of the retrieved record, right? Again, this is a retrieved record over here. Is repeated. Actually, are repeated because we do different checks. Right? So every time you're trying to do some retrieval, you have to repeat this particular structure. For Jim, you got to repeat once. For Jeremy, you got to repeat the second time. And for every possible place in your code, you have to repeat it every time you do it. right? Let's say this. Let's say you got 2 repetitions already in your code, right? Let's say what if this by the way, this already violates is a good indication that we violate the single choice principle since we got duplicates in our code. Let's now see 2 problematic scenarios where the duplicates will really make it very difficult for you to make new changes. Number 1, over here. What if a new type C101 is actually introduced, right? We said before we only got 100 C1 up to C100 dynamic types. What if we want to introduce one more dynamic type? Let's say C101. Well, what you should do is you should really make sure for every repetition for the exhaustive check structure, you have to repeat the following. You got to say maybe else if over here, if the record instance of C101. In that case, you got to do the corresponding cast. Similarly, over here for the second repetition, you also got to expand it by saying else if. You got to say record instance of C101, and then you will do the save cast, right? You can see since we got 2 repetitions, so that means for the new dynamic types we have to repeat it twice, 1 time and also 2 times, right? Already. But what if you got 100 repetitions in your code? That means you got to do for 100 times for repeating this new change over here, right? Similarly, what if the type, let's say C100 becomes obsolete? Let's say we don't want that class anymore to be checked. In that case, you have to delete this line. Let me just show that to you. Let me use maybe orange. Let's say this one here is obsolete. So that means what you got to do is you got to delete this line over here from your code. And also you want to, let me just make it a little bit thinner, okay, so you can still see it. We want to delete this line over here from the first repetition. We also want to delete this line over here from the second repetition. You're still going to repeat the changes in multiple places, right? So that's why the single choice principle is actually violated, right? If you're wondering about what the single choice principle really is, you can refer back to the first part for the inheritance lecture where we spoke about the principle in more detail. Okay, so that's about why the general book design is actually not very ideal. Let's now see very quickly about what an ideal solution might be, and then we'll move on to that, which will be generics. All right, so that's the slides I just spoke about in detail on the iPad. So we need a solution such that it will prevent us from it will save us from writing explicit instance of checks and also typecasts, right? We don't want to repeat that every time we actually want to retrieve something from the general book, if possible. And also we want to eliminate the occurrence of class cast exception. In some way in the general book, it seems to be impossible because the reason that the exact reason for having these two is because we want to prevent class cast exception. But now we want to say both of them, we don't want to have them. Is it possible? It turns out it is possible. But let's now take a look at the criteria for an ideal solution. But it's up to this point, you should really know these two things will catch the essence of the general book solution. You want to understand why this part, this is the good intention for the general book design. But this point over here is really what's causing the design principle, single choice principle, to be violated. Okay, so ideal solution should be when the user declare a book, we want to say rather than general book, we want the user to somehow indicate and commit to the kind of record that they want to store at the runtime. If they want to store dates only, they store dates. If they want to store maybe a string only, they only store string. They don't really store a mix of the different kinds of record. So that's the idea, not a mix. Okay, that's the criteria number one. Number two, when we are trying to store into the book, we don't want to be as accommodating as before, right? Whatever the user declares the kind of record they want to store in the beginning, we want to stick to it. So that means, for example, if they say I want to commit to storing dates only, in that case, if you actually try to store any objects whose static type is not the descending clause of the dates which you committed to, in that case, there should be some compilation error, right? That's something we'll see exactly. And criteria number three, whenever you want to retrieve a record from the objects as a record object from the book, right? This case, since we initially commit to the kind of objects of record that we want to store in the book, and we kind of enforce that particular rule very strictly whenever we want to store something into the book. So now if we want to retrieve something from the book, we will be able to make some more useful assumption. Rather than simply knowing that we are retrieving an object from the book, we can know that we are retrieving, for example, a date from the book, right? So these are the three criteria for an ideal solution. You might be wondering to yourself, is there such a solution? Indeed, there is. Well, we'll get to that. That's exactly what generics is about, which we'll go over together with you the syntax. Okay, so one more slide, just about parameters, because generics is really about parameterizing the types for the various parameter types when we return types into some parameter, and that can be instantiated when you actually want to use the book, right? That's something I want to let you go over this slide over here. So this part here is just about whenever you observe the pattern for addition, for example, 2 plus 3, 1 plus 1, 1 plus 1, etc. The operands 2, 3, 1, and 1. So these are just the argument value. So these are instances of applying the operation. And we want to generalize them into different parameters to say parameter number 1 is simply an integer like 3. And parameter number 2 is like an integer like 3 over here, second parameter. That's something you really have been doing in your math class, but without being explicitly told, maybe. In Java programming, we talk about method parameters, right? So for example, when we observe, this is how you should call the deposit method, let's say with deposit 100, deposit 23. But when you actually implement the method, you don't really just put some specific values over here. Instead, you will actually do the parameter like this. You would say, every time I want to call the deposit method, I want some integer parameter called the amount. And the amount over here can be instantiated to any type compatible value over here, 100, 23, 46, and etc. Okay, so that's the idea about parameter. Every time you want to derive a general solution for a set of example computations, you really need the idea about parameter, which is simply just a variable that can actually be referred to throughout your solution implementation. We have seen how the parameter can be used in the case of, let's say, method implementation, right? And now we're going to see a different use of the idea about parameter, which means I want to parameterize the types of the attributes into some parameter variable that I can actually commit to or instantiate into at the runtime. That's something we'll see. All right, so we are actually running out of time, unfortunately, for this week. But I would say we'll stop here. And up to this point, you should really review all the aspects about what a general book is and also its drawbacks for its design with respect to single choice principle. And next week, we actually continue to finish off this lecture. We don't have that much to finish, which is just about the syntax and also some example code to go over with you about Java generics.